Hello everyone, this is a worksheet called Sketching Derivatives. It goes along with the lesson D2, and you can find both of those, the blank worksheet and lesson D2, in lesson notes. So there are 5 functions in this worksheet, and we are asked to sketch the derivative for each function. Let's start with the first one, which is a line. So f is the graph on the top, and we are asked to sketch f prime. I'm just going to ask you to change the scale on this graph on the y-axis. Let's make it 1, 2, negative 1, 2. Okay, so we have a graph here with a constant slope. The derivative just means the slope. So in a line, there's only one slope, and that slope for this line, because this is the line y is equal to x, you can see that, 10, 10 is on the line, for example. So, and it goes through the origin. So that's a straight line of slope 1. So the derivative has to be 1 everywhere. So we just come to 1 as a y value and draw a straight line at 1. That means that the derivative is 1 everywhere. If you want to know the derivative at a random point on the f graph, you have to come down to this graph and read the y value, which would be equal to 1, because in this graph, all the slopes are always 1. Okay, let's talk about a curve like a parabola. So in this, the top graph is f, and I'm going to draw f prime on the bottom. I like to come to a curve and look for horizontal tangent lines. So right here at x is equal to 0, I can see that the tangent line is 0, so the slope. So I can put a 0 for y value on my f prime graph. Then I'm going to notice that as you go toward x positive values, you're going to find the tangent line slopes are all positive, right? So they're definitely all positive slopes here. And they're also all increasing, right? As you move right, the slopes are increasing. So you can estimate what the slopes are by doing a little bit, draw an accurate tangent line and think about the rise over the run. But what we're looking for here is for you to make sure that your y values are positive and increasing on the right side of 0. On the left side of 0, in the parabola, right, for all of anything less than 0, for x negative, you are noticing that the tangent line slopes are negative, and also that as you come closer and closer to 0, your negative numbers are, closer and closer to 0. So in other words, when you're far away from 0, you have a slope that's maybe negative 6 or something, and then as you come in, it's negative 4, negative 2, negative 1, until it hits 0, right? So the whole graph, if I were to just draw it as one line, would look something like that. That is our f prime graph for the parabola. Okay, how do we deal with some of these kind of more curvy graphs that you might see on the homework? You're going to be asked to match a function to its derivative. So let's think about that. The first thing that I would look at, again, is the horizontal tangent lines. So I have at this x value here, which looks like, it's about negative 0.6. I have a 0 tangent line, a slope 0 tangent line. At roughly there at a half or so, I have another slope 0 tangent line. And then if you look here, then roughly at, a bit past 1.6, I have another 0 tangent line, right? So I'm going to come to this graph, and I'm going to be precise here, and I'm going to say, right at this exact x value, I need a 0 on my f prime graph. And then right around there, I need another 0. If you need to draw the line like this to match up your x values, then please do that. And when you're matching in a multiple choice question, this is one of the best things to look for. Where are my tangent lines equal to 0 slope? That's where f prime is going to be equal to 0. We're going to look at the SIGNs of slopes, right? So for now, this stretch right here, this green stretch right here, all of this, my tangent line slopes are negative. So let's say m negative over there, as well as over here. These are places where tangent line slopes are going to be negative. And then over here, tangent line slopes are going to be positive. So the green areas, I have negative tangent line slopes, and the red areas, I have positive tangent line slopes. We're also going to be noticing, if you are carefully looking at what's happening to the tangent line as we come in this stretch, for example, you can see it's like positive, more positive, more positive, more positive, more positive, and then it's still positive, but it's getting less and less positive as you come in to x is equal to 1/2. So the derivative graph has to kind of increase and then come to a maximum right there at x is equal to 0 and then go back down, okay? And then likewise, when you do this green section here between 1/2 and 1.5, it's going to go negative, and then right around here, it's going to keep on going more and more negative, and then less and less negative, and then come back. And then if you look past 1.5 is around here, or 1.6, call it, right? From there on out, my slopes are just getting more and more positive, so the slope number is getting bigger and bigger as I go out from there. And then to the left of this negative 0.6 here, to the left of that x value, I have negative, very negative slopes, and they get less and less negative as I come in to x is equal to -6, where negative 0.6, where I have a 0 slope. So that's kind of the thinking on these questions. We'll quickly do the last two. This one, again, I would first find my 0 tangent lines like that and match it up to f prime equals 0 spots. And if you look at this carefully, you're going to see it's a sine graph. And so we're going to have f prime equals 0 at all the places where the sine graph is hitting its maximum. And then we're going to have negative slopes in here and positive slopes in these stretches, blue stretches. And then, like I described before, if you look at, for example, from negative pi over 2 to positive pi over 2, the slopes are first increasing. They're always positive in that stretch, but they're first increasing and then they are decreasing. And so if you look at a graph of f prime, it's going to first increase and then decrease. And it's going to do the same kind of thing for the negative slopes. So you're going to end up with something that looks like that. Something like that looks like that. Okay, and then the last one we're going to do is this straight line graph. Remember, guys, on a straight line, the derivative is just the slope of the line. So it's like some of you are taking physics. So think of this as a position graph, and then you're drawing the velocity graph. Here, the position is not changing in this first stretch, so the velocity is 0. Then here, the position is changing at a slope of -1, so the velocity is going to be -1, and then +1, and then -1 again, and then 0 for the last stretch. Important to note that sharp corners, right, are not differentiable. Discontinuities are not differentiable. And so for those places, we're going to leave it as an open circle on our derivative. There is no derivative at those places. Okay? I hope that made sense. Have a great rest of your day.